Hello everyone, welcome to my new video, and in this video we will solve a complex equation in the complex space C. And as usual, before we actually start with the content of our video, I would like to thank you for the support you show towards my channel and my whole project, and I invite you to continue to show this support, subscribing to my channel, hitting that subscribe button and that like button. And if you want to stay always updated with my latest releases, you can also click the bell button. And of course, if you want to support me, let's say in a more material way, you can also donate me via my PayPal and my Ko-Fi, and I will leave the links in the description below. Then, after the usual YouTube introduction, we start with our exercise, and we want to solve the complex equation in C. So we have the following equation. It's very simple. We want to start very easy. We have z squared is equal to 6 times z star, which stands for the complex conjugate. So considering that we have this kind of equation with basically the power operator and the complex conjugate operator, the most convenient way to solve this type of equation is to represent the complex number via its algebraic form. So we write z squared, it's nothing but x plus I times y squared, which is equal to 6 times z complex conjugate. We have to write x minus I times y. So we expand the square here, and we have x squared plus 2ixy minus epsilon squared is equal to 6 times x minus iy. So now basically we have arrived where we wanted to arrive, because now we have to separate the equation in its real part and imaginary part, and we have to equate these parts between the left hand side and the right hand side of the equation. So we highlight the real part. So we have x squared minus epsilon squared here, and this is the real part here. Okay, then we have the imaginary part here, and here we also have this 6. And so we can write this system of simultaneous equations. These are two equations, one for the real part and one for the imaginary part. So for the real part we have x squared minus y squared is equal to 6 times x. Perfect. And then for the imaginary part we have 2 times xy is equal to 6 times y with a minus. Okay, and then we rearrange these equations. Are x squared minus epsilon squared is equal to 6 times x, and this is equal to 2xy plus 6y equal to 0. And then we can factor out an epsilon. We can factor out an epsilon, and we can write epsilon, which multiplies 2x plus 6 equal to 0. And then now we can guess our solution by simple inspection of the system. So let's go to another page. We rewrite our system to have it to have everything in a single page. We have x squared minus y squared is equal to 6x, and then we have y, which multiplies 2 times x plus 6 equal to 0. Perfect. So we can start and we can say, okay, we start with y equal to 0. Then here we have a little box with solutions, and I'll actually open this box because probably it is too small. So we start with y equal to 0 and we write it here, and with y equal to 0 the second equation is automatically solved because y is factored out, and it makes the whole equation equal to 0. Perfect. Then we have to solve this other one, and we have x squared minus y is set to 0, so we only have 6y. We can write it as x squared minus 6x is equal to 0. We can factor out an x and write x, which multiplies x minus 6, and this is equal to 0. And so we have two solutions here. We have x equal to 0 and x equal to 6. So we can write it. We can write our equation here. We have y equal to 0 and we have x equal to 0. We have to excuse me, sometimes I say y equal to 0 because I am from Italy, but it's actually y equal to 0. Okay, I hope you will understand me. And this is x equal to 6. So we have as complex solutions, we have z equal to 0 and z equal to 6. So we have the, let's say, not so interesting solution z equal to 0, and we have the real solution z equal to 6. Perfect. Let's try to find the other solutions. So now we solve this other equation here. Basically the whole system can be solved considering this linear equation here, and we have 2x plus 6 equal to 0, which means that we have 2x is equal to minus 6, and then x is equal to minus 6 over 2, which is actually equal to minus 3. Perfect. So now we have minus 3. We can substitute the solution here in the first equation. We have minus 3 squared, it gives 9, minus y squared minus y squared is equal to 6 times minus 3. Okay, and this is 9 minus y squared is equal to minus 18. So now we have y squared, which is equal to 18 plus 9, which equates to 27. And so now we have that y is equal to plus minus square root of 27, which I can write as plus minus square root of 3 raised to the third power. Then we can factor out a 3, and we have plus minus 3 square root of 3, and then we can write our final solutions are as we have x equal to minus 3 and x equal to minus 3. So we have two solutions because they are associated with a second order solution, a second order equation, and we have y equal to 3, which multiplies square root of 3, and the other one is y, which multiplies minus 3 square root of 3. Then as a complex solution, this can be written as z is equal to minus 3 plus I 3 square root of 3, and this other one is z is equal to, I will write it here, minus 3 minus I, which multiplies 3 square root of 3. So we can see that these two solutions, the complex solutions, okay, are actually complex conjugated. This is a very important consequence of the theory of algebraic equations. So with this exercise I will stop here, and we will continue with more exercises on solving complex equations. And for this video I would really like to thank you for your attention, and let's see you on the next video.